Now we introduce unsupervised learning for physical reactions through video prediction. Artificial intelligence means we first understand human intelligence and then put this intelligence on the machine that the machine can do as a human. So right now we introduce the video prediction. This video prediction is let the agent to fully understand the environment, and then can, without the supervision, just by their own exploration, to move object from point 1 to point B. So in this way, we don't need we don't require many labeled data. That's the primary idea. It's called action conditioned video prediction. That means, based on the previous image, we add action and put the internal state of the robot into the lower feature of the input image. We predict the new image until we reach the terminal position. The architecture of the convolutional dynamic neural advection model, the basic idea is structure is here. For example, at t-1 step, we have a RGB input image. Then we use convolutional LSTM to predict the first extract the feature, in the lower dimensional space, and then we predict the new image or new frame. That means we calculate, we know the object distribution in the previous image. We need to predict the object distribution in the new image. New image include the two steps. First, we calculate the mask like a weight distribution. That means, we calculate the appearance. And then from the lower feature map, we get a conventional kernel for each object. For example, we are interested in 10 objects, we have 10 kernels, and we have 11 masks. 11 masks means that's an actual one is for the initial image I0, like a background. And then we combine, we apply this kernel into the previous image, we get the object position and transmission in the new image, and we compose the corresponding mask with the transformation together. We get the object position and appearance in new image for each object. And then we combine all the objects together to get the final image. That's the idea. The so-called dynamic neural advection model is first is predict the each pixel in the previous image and see what the expectation in the new image. That means, for example, for this one, what's the possible position in next image. For each, we predict the expectation for each pixels in the previous image, then finally we get a new image. think about if object include multi pixels, they'll follow same transformation. So we don't need to work on a pixel by pixel. We can one time work on one object. This way we improve the efficiency of the transformation. So that means for example, we get the transformation. We got a transformation. We apply this transformation to previous to each object in the previous image, and then we get the object position in a new image. This is just like transformation. This is corresponding, the position of object in the previous image and what's the new position in the new image. And then we combine with the mask to get the real, object in the new image. That's an idea. Since we get the prediction for each object, then we need to combine those objects together to get a final single image. So we need to combine the transformation and the mask, add up them together to get a new image. Since we have from a layer convolution layer 2, we got 11 channels. This 11 channels is separate. But finally, we need to combine them into one single image. So we need to apply softmax, make sure get the reasonable or get the valid final single image. So we need to apply softmax to these channels, get the normalized mask distribution. So use this way, use this video prediction, we can predict when we add one action to the robot, predicted what's the next image. Use this way, we let the agent fully understand the environment, and then we don't need we don't need a large number training data, just like for the supervised learning method. For more detailed information, can check with this reference. Thank you.